is aldehydic functionality, and this whole group we are taking as one group of compounds, ठीक है। इस सब को हम एक पूरा ग्रुप लेते हैं, तो इसके नतीजे में हमारे पास एक कार्बन जो है 4 डिफरेंट ग्रुप्स के साथ अटैच हैं, इसको हम कायरल कार्बन कहते हैं, ठीक है। Since in hexose there are 4 chiral centers, these chiral centers show its stereochemistry. So this Fisher projection are used to represent stereochemistry in carbohydrate. In Fisher projection, horizontal lines are understood to project out of the plane towards the reader. When you are writing in a paper, these horizontal, there are 2 types of line. One is vertical line and another is horizontal line, right? So these horizontal line are in Fisher projection, horizontal lines are understood to project out of the plane towards the reader की तरफ, and the vertical lines are understood to project behind the plane. Suppose you see here, these are behind the plane, and these are horizontal lines are understood to project out of the plane towards the reader, while vertical lines are understood to project behind the plane, right? 3-dimensional structure होता है basically ये 3-dimensional structure. When you use models, you will understand the 3-dimensional structure of molecules. So in Fisher projection cannot be removed from the plane of the paper or turn 90 degree and still represent the molecular accurately. So पेपर में हम 3-dimensional structure हम शो नहीं कर सकते हैं, लेकिन जो horizontal lines हैं वो above the plane होती हैं, और जो vertical lines होती हैं वो behind the plane होती हैं, ठीक है। So in short, ये जो these bold lines are represented as beta. Suppose this one is beta hydroxy, and the stereochemistry of this CH2OH, this is alpha, right? This is represented as alpha. So basically, there are 4 chiral centers in a carbohydrate. These 4 chiral centers show its stereochemistry. So vertical lines behind the plane and a horizontal line above the plane, which are shown as beta, vertical lines shown as alpha, like this one, dashed one, right? Dash, dash, dash. So this is called stereochemistry. You will be offered a subject in higher in next semester. I think there is a full length course offered. Stereochemistry full length course will be offered, right? So this Fisher projection formula we can also shown like this one, circle and line formula, and this is complete stereochemistry, right? We show this molecule, this hexose, with complete stereochemistry with wedge line, dash, and wedge formula. One is beta, the horizontal lines are beta, and the vertical lines are alpha, that is behind the plane, and the vertical lines are above the plane, right? Similarly, we can very well in muta-rotation this glucose convert into closed chain, convert into open chain, then again convert into closed chain. So this highest stereogenic center, that is carbon number 5, hydroxy of carbon number 5 react with this carbonyl group, lead to the formation of this cyclic structure. So this is called Haworth's formula, right? So basically Haworth's formula show another configuration, alpha and beta. So this one is called alpha if hydroxy towards downward and hydroxy towards upward, that is called alpha. So this Haworth formula, that is in cyclic structure basically, and that is in cyclic structure, the flat cyclic representation of carbohydrate is called a Haworth formula, right? जो flat cyclic structure होता है इसको हम Haworth formula कहते हैं, cyclic, but basically cyclic glucose actually exists in the chair form. This cyclic glucose, which is a 6-member structure, 6-member cyclic structure that are basically exist in chair form. In chair form, I have already mentioned you yesterday, each carbon having one hydrogen and a hydroxy in carbohydrate. So this position is called axial position, and this position is called equatorial position. Suppose each carbon have one axial position and one group in equatorial position. Suppose this one is equatorial position, and this one is equatorial position, and this one is equatorial position. This one is equatorial position, and this also exists in equatorial position. But their hydrogens are exist in axial position. ठीक है, इनके जो हाइड्रोजन्स हैं वो एक्सियल पोजीशन में एग्जिस्ट करते हैं इसी तरह से. So in alpha glucopyranose, that in chair conformation in hydroxy, if exist in axial position, so it is called alpha. If hydroxy exists in equatorial position, then it is called a beta configuration, right? So if you just write in Haworth's formula, if this hydroxy towards downward, then it's called alpha, and if it is towards upward, then it's called beta. Right? So basically, we are through Fischer configuration, we will try to confirm its stereochemistry. Any question?